Stanford University.
Okay, well, welcome to lecture number 9 of CS193P. And today we are going to do table views. It's quite a bit to cover, and I have a pretty extensive demo that I want to do. So I'm going to kind of zoom through the slides pretty quickly, as I am wont to do, because seeing it in the demo is ever that much more instructive. So the table view is a very important UI view in iOS, and it can be used to basically present a list of dynamic data, right? Data that you're pulling out of a database or somehow else calculating. It can also be used for static data, and I'll show you some images when you would want a static table, okay, a table whose contents are kind of fixed. Some of the things in the table might be set at runtime, but it's not like a list whose length is varying. The demo I'm going to do today is obviously going to demo table view, but I'm also going to demo a protocol with the delegate one more time. Okay, I've done that 2 separate demos, but I know that this is the whole delegation thing. Sometimes a little hard to really get your mind around, so I'm going to do it one more time. Hopefully we'll have time to get it all in today, just so you can see it happen again. And what I'm going to do is I'm going to add a favorite graphs button to your assignment 3. Okay. All right, so table view. It's a one-dimensional table. It's called a table, and people think of a table as like a 2D table, rows and columns. But really, it's one-dimensional or 1.5 dimensional. We sometimes say about table view because of sections, and you'll see that in a second. It's a subclass UI scroll view, right? So it's a scrolling list. And it can be static or dynamic. Static meaning the thing's in fixed. Dynamic means it's a list of items that's pulled from somewhere. And it's very customizable. It gets all its customization from 2 different delegation things it has. It has a data source and it has a delegate, both. 2 different properties. And the data source is responsible for providing the data that's going to be in the table, and the delegate is responsible for kind of how the data is displayed and things like that. So this is the first time we've seen an object that has both a delegate and a data source, right? Your calculator had only a data source. So that's kind of cool to see. And you've seen things like split view control have only a delegate because they have no data, right? It's very efficient in terms of displaying very large data sets. So like if your iPod library has 10,000 songs in it, it's very efficient. It's almost as efficient as if you only had 1,000, right? It's really built for speed from the start, and also memory usage. If you want to display multidimensional data, you know, rows and columns, you can use the sections, which I'll talk about in a second, or you're going to put this thing inside of a navigation controller, right? So you're going to click on a row, and it's going to push on what would be across the columns of that row, if you want to think spreadsheet style. So that's the way you can do multidimensional, and you can kind of keep going as deep as you want. You click on your albums list, which is a table view, and it takes you to the songs list, and you click on the songs list, and it might take you to, you know, I don't know, the lyrics or something, or even more, let's say artist, and then album, and then song, and then thing. So you can keep drilling down with these lists. Very common to do that. The table views, roughly dividing them up into kinds of table views, and these things can work together, but you generally have a plain style table view or a grouped one, and we'll see what that looks like. You have static or dynamic, I mentioned that. It's divided into sections or not, kind of have mentioned that but not shown you. And there's also different formats for what appears in each row. What appears in each row is a UI view, and so it's very, very highly customizable. So that's a lot of words. Let me show you some screenshots so that you can understand. So here's what a plain style table view looks like, right? It's what you're probably used to. In fact, this one has a section header, the F at the top there, at the start of the albums that begin with an F. That F is a section header. The thing on the bottom is a tab bar controller, which we haven't talked about yet. Not related to table view. And then here's a group style. And in the group style, you see how they're kind of little rounded rects grouping the sections. And so the group style tends to be more used for fixed table views, for things like settings. Like if you go on your iPhone and go to settings, you're going to see it uses a table view. It's a grouped table view. Whereas the list view, again, tends to be a thing for viewing dynamic data. Let me kind of go through some of the terminology, the words we use to describe all the parts of a table view. So here's a plain style table view. The thing at the very top there is called the header. Okay, that's a UI view that you can add to the table, and it can have anything you want in there. That might have like maybe a search bar or something else related to the whole table. And similarly, you have a footer at the bottom, another UI view. This group of things is called a section. And so a table can have sections or not. If it has sections, then it'll have these little section headers, like where it says header 1. Is that what it says there? I can barely see this. Yes, header 1. And then that section has 2 rows. Okay, so the section is the whole thing, and then the rows are the individual rows. And then the blue bar is called the section header. You can set the section header by string, like the string that uses the section header, or you can actually put a view in there. Okay, in later versions of iOS, like iOS 4 and beyond, it can actually be a view. Also, sections have footers. Each row in the table, okay, the thing that's not a section header or a footer and not the header and footer view, each row is a UI view. And we call that UI view a table view cell. Okay, so that's the word we use to mean that. And so that's the summary of that. And we use exactly the same terms to describe the group style. So here's what the group style looks like with all those things. Okay, so the section headers are there. They're above the rounded rects. You can still have a header and footer on the table. The rows are inside these little rounded rects. Okay? Understand that? So let's look at sections or not. So here is a table on the left that has no sections. So it's just cities and some geographical data on the left. And on the right, though, it's divided up by country. Okay? So each of the countries is a different section. The rows in that are in different sections. So when you are building a table view and you implement your data source, you tell the table view how many sections you have, and then it's going to ask you for every section how many rows are in that section. Okay? So some sections might have only 1 row in it. Some sections might have 100 rows. Okay? So that's kind of a way, that's what we call it 1.5 dimensional. The sections can give you a little more dimension. Then another degree of freedom for displaying this is the type of cell. And so there's 4 basic types of cells, and then there's also a custom cell where you can do anything you want. It's a UI view. You can add buttons or switches or whatever you want to it. But here's the 4 basic types. There's the subtitle, okay, which has a title kind of in bold and then a little gray subtitle underneath. There's basic that has no little underneath thing. There's right detail, which is the same as the subtitle. It's just the stuff is arranged differently. Okay, it's on the side and it's blue instead of being underneath. And then left detail, same thing, but they're swapped around. Okay, so you've probably seen all these different kinds of cells in different apps, like settings tend to use the left detail, and most other kind of just generic lists tend to use the subtitle mode. And we're going to see in Xcode how we can set what the type is. All right, so creating table view, model view controllers. How do we do this? Very straightforward, and you should be used to this by now. The table view comes in a model. It comes inside of a. It comes prepackaged, let's say, in Xcode with a class called the UI table view controller. So there's a class in iOS for the controller, and then there's a class for the view, the table view, and you kind of drag them out as one unit from the object library. So you can see here on the screen, I'm kind of dragging out a UI table view controller, and when you drop it, you get what you'd expect, a view controller. It's of class UI table view controller. Now, you're usually never going to use this thing in a generic UI table view controller because you usually subclass it and make it that controller be the data source and delegate, and you go implement those methods, and that's how you kind of make the table view do what you want. So how do we create a new class, make this table view controller not be a generic UI table view controller? Same way we do for everything else, right? We go to new file, we click on UI view controller instead of Objective-C class. We take UI view controller. We type in the name, so this one I guess called my table view controller. It looks like there. And one very important thing is to make sure you set the class, the superclass of your custom controller, to be a table view. If you don't do that, then it's not going to work. Okay? The UI table view controller class in iOS does some things that help get your table view hooked up to your subclass. So you definitely want to make sure you pick that. And then you'll also want to make sure that in your storyboard, you inspect that controller and go to the identity inspector and set its class. Just like you did when you dragged out a generic UI view and you changed it to be a graph view. Hopefully you all did that in your assignment number 3. Same thing here. We're dragging out a generic table view controller and we're going and changing its class to be this custom class we just created with new file. Everyone with me so far? Okay, so now I have a table view controller out there. It's a subclass, some custom subclass of UI table view controller. It's got a table view in it if you look at the bottom there. And in fact, if I click on the table view at the kind of the middle of this controller, then and move to the attributes inspector, I'll be inspecting the table view. So you should see the table view attributes right there. There's some interesting attributes here to set in the table view itself. Okay, we're not talking about the cells in the table view, but we're talking about the table view itself. The most important one is whether you want a dynamic table that you're going to supply all the data, and it could be any number of rows, or whether you want a static table where it's like you're going to set the number of rows in Xcode, and then you'll fill up. Maybe you might fill the data up in the rows in your code, but there's going to kind of be a fixed number of rows. So let's switch to static first and look at the static table here. So I flipped that thing to static, and so this table view is a plain style. You see how it's not putting the rounded rects around thing, but we could change that. Okay, we just go flip there to group style. So now we have the group style one. Really, there's not a whole lot else to say about the table view except for whether it's static or dynamic and its style, a couple other things, but those are the main things. Most of the customization of the look of the thing happens by customizing the cells. So now we're going to click on one of the cells inside the table view and look at some of the properties we can set there. So the attributes inspector on the right now has switched, you'll see, to showing a table view cell, which is a UI view, subclass of UI view. And it has some built-in things that you can change. For example, remember we saw subtitle, basic, left detail, right detail. Well, you can set that here with this pop-up right there. So there's basic, there's right detail, there's left detail, and there's subtitle. Okay? So you can set that. You can also directly double-click, just like you could on a UI label or a button title. Just double-click and set the text to whatever you want. Okay? This is a static table view, so that would make sense. If it was dynamic, this wouldn't really make sense because you're going to load up the table. Even a static table, you might not be editing directly in Xcode. You still might be setting it from code, and we'll see how we set the cell from code in a moment. You can also control the little thing that appears on the very right of a cell. That's called its accessory. So the choices here are there's a disclosure accessory. That wants to be there any time that clicking on this cell is going to segue. Okay, if clicking on the cell segues to something else, either pushing something on a navigation controller or maybe changing the right side of a split view, then you want that disclosure accessory to be there. That's what tells the user that that's going to happen. There's also a check mark accessory. So you can use a table view as kind of like a radio button where maybe there's 5 things in there and you click on one and it's whichever one you click on gets a check mark and the others get cleared. You could also use it for a multi-selection thing where you click on things and then it gets a check mark, you click on again, the check mark goes off. And it's totally up to you to control whether the check marks are on. So in Xcode you're just kind of setting the initial state, but in your code you would set that check mark accessory. And then there's also this kind of funny one. It's called a detail disclosure accessory, as opposed to just disclosure accessory. This one is actually a button. Okay, so it's got the little arrow. So a user looking at this is going to think, rightly so, that if I click here, it's going to segue, it's going to go somewhere. That's true. But if I click right on the little round blue button, then it's going to do something else. Okay. Usually, what's going to happen here? Let's say. For example, looking ahead to your homework a little bit, you're going to have a list of photos. And if you click on the row, it might show the photo. But if you click on the little blue button, maybe it tells you something about the photo, like where it was taken, who took it, things like that, right? So it's providing some ancillary information. But the primary information is clicking on the row, the little blue button. is just for ancillary information. And the way that you kind of hook up that, the way you hook up that little blue button is in the delegate of your table view. You implement this method, accessory tap for row at index path, and we'll talk about these index paths and how we find out what was clicked and stuff like that. But that's the magic method that's going to get called if the person clicks on that tiny blue button. Question? Yeah, so the question is, if I click on the little blue button, could it segue as well? Because we know that clicking in the row, if it has a disclosure icon, it's going to segue. Could the blue one segue? And absolutely it would, especially on an iPhone. Where else are you going to display the information? You kind of have to segue. So yeah, it probably would segue just to a different place than clicking on the row would. Okay, so don't worry too much about that method. I'm just putting it here for reference purposes. We'll see how that stuff all works. Some cells in some styles, like the subtitle style and the basic style, can have an image also. So here, if you look, I'm going through the pop-up here and I'm picking this Stanford logo image, and when I choose it, then it appears on the left. Okay, the image always appears on the left. All right, and you can set that from code too. All these things that we're setting with switches and stuff in Xcode, we can set it from code as well, and I'll show you where that happens. Then there's a very interesting style, which is the custom style. So I've changed this style to be custom. If you look at the top there, it says custom now instead of subtitle or basic or whatever. And I can actually now just start building it like a view. So here I'm dragging a button out, right, into the cell. And I just wire it up using control drag. The answer is you might have multiple scenes, okay, table view, instances of UI table view controller that you drag out, of the same class, your custom subclass, but they might have different cell prototypes. Okay? So we name the cell prototypes here, and you're going to see in a couple of slides here, we're going to type that name into our code. And that's how we make the link here between the two. This can be a little frustrating if you forget to type it in one place or the other, or you type a different word in one or the other. But this is an important thing to pay attention to. All right? Normally we try to put the reused identifier to describe what's in this cell. Okay? So the name I put there is not a very good name, but things like photo description, if this was a list of photos, that would be a good name for this cell, okay, description of the photo. Okay, so how does this all work? We got all this UI, we built up these things, we set all these settings. How does the data flow back and forth? And this is all done via protocols, okay, so this thing about protocols, they may seem complicated to you in some ways, but they're a fundamental computer science element that we need to drive what we do in iOS. And this is a classic example of where protocols really are great. And the table view has two different delegates. Okay, one's called the delegate and one's called the data source. And they're just protocols. Not all, unlike split view controller or scroll view, not all the methods in them are optional. Okay, the data source one has two required methods in its protocol, which we'll see in a second. The delegate are all optional ones. The UI table view controller, that class, automatically sets itself as both the delegate and the data source to the table view that's inside of it. So when we drag that table view controller out, and it already had a table view there, that controller, which we subclassed, that our subclass is the data source and the delegate by default. And this is almost always the way you use the table view. You could specify some other random object to be the delegate or data source, but usually it's the controller. Now, why do we do this delegation? Because remember, views cannot talk to their controllers except through blind communication. And that's what a protocol is. It's communicating through an ID, but with this protocol on it that says what kind of messages are going to go back and forth. Okay? So the table view is the view for this controller. So we can only talk back to it being target action or the delegates, or could have outlets into it too. Okay, there is a property in UI table view controller which points to the table view, to its view. Okay. So to be dynamic, we have to implement this data source protocol. Okay, for static we don't, although we usually do. Unless it's truly static, like everything's just edited in Xcode and that's it. But for dynamic, we have to implement this data source. So what is in this data source protocol? What are some of the methods in it? Well, there's three really important methods that we have to implement. One says how many sections are in this table, which often is one, but sometimes more than one. Two is how many rows are in each section, so it's going to ask you repeatedly for each section. And then third is give me the UI table view cell to draw each row. Those are the three methods. Okay? And we have to implement those. There's a bunch of other methods, but those are the three absolute musts. So let's look at the last one, the one that is give me the UI view, the UI table view cell that is going to draw a certain row. This is what that method looks like. It's called table view cell for row at index path. As with all delegates and data sources that we've seen, it always passes the sender, right? So the table view that's asking you for the cell at the row at index path is passing itself as the first argument. And then the second argument is an index path. Now, static cells, again, don't need to implement this because you might have typed it in Xcode, so they don't need the cell for row and index path. They don't need the UI table view cell. It's already built into Xcode, but in dynamic, you definitely need it. NS index path is a very simple little object. All it does is encapsulates a section and a row. That's all. Okay, so it has two properties, one called section, one called row. It has some other stuff, but those are for table view. Section and row is all you need. And section will tell you which section we're talking about, and row will tell you which row in that section. So this method is just saying, give me a UI table view cell, which will draw this row in this section. And it's just passing the row and section in this NS index path. Okay, so what would the code look like in something like this? Well, usually there's two parts to it. The first part is get myself a cell somehow. I need a cell, so make one or get it somehow. We'll talk about how that happens. And then I set properties on the cell, like the image, like that Stanford logo, or the disclosure accessory, or a check mark, or the text, or the subtitle text. We just set all that up. Bam, that's it. So it's as simple as that. It's very straightforward. The first part of it, some people get a little confused, but it's really not that difficult to understand what's going on here. There's a magic method, a very important method in table view called DQ reusable cell with identifier. And what this does, DQ reusable cell with identifier, the table view manages like a little pool of these UI table view cells. This is for efficiency, right? Because again, if I have 10,000 items, I don't want 10,000 UI views. That would be incredibly inefficient, especially since only 8 or 9 of them can be on screen at one time, okay, on an iPhone. So the UI table view manages a pool of them. And as UI table views go off the screen, they scroll off the bottom of the screen or off the top, it puts them in the pool, okay? And then when one has to come on screen, it goes into the pool and gets one. So you see how it's just reusing them? And it works fine because every time we get a new one and pull it out of this, DQ it out of this reusability pool, we're setting all the values of the cell. So it's perfectly fine. We just keep reusing them and resetting the values as they come on screen and go off screen. Now, the tricky thing, though, about this reuse identifier just specifies the name of the pool to use. Okay? And the tricky thing about this, though, is when we do the Xcode prototype cells. Remember we did the Xcode prototype cell, and we gave it a name. And remember I said pick a good name, and I told you you'd have to type in the code. Well, here's where we type it in. Because when you do an Xcode prototype cell, if it reaches into the reuse pool and there's nothing in there, like when it first starts drawing, there's nothing in there, and when it first draws the very first cell, it will create one and put it in there using the prototype. Does everyone understand? Okay, so that's what that prototype cell is doing. It's populating that reuse pool when it's empty. Okay, anytime it's empty, it gets populated by a copy of that prototype. So that's what's going on here with this DQ. So obviously this string needs to be the same thing that's in Xcode if you want that prototype population to happen. What happens if this thing returns nil? Okay, we call this DQ reusable cell, and there's nothing in the pool, and we didn't specify the same string as Xcode, so it can't make a prototype copy, so can't get anything. It returns nil. In the case that it returns nil, we're actually going to put a little bit of safety code in here and alloc and init a cell. Okay, the designated constructor or the designated initializer for UI table view cell is init with style reuse identifier, and that's just specifying the style like subtitle, basic, left detail, right detail, all that. And then the reuse identifier is which pool this thing should go into when it stops being used, right, when it frees up because it's not on screen anymore. Okay? Everyone cool with that? So that's how we get a cell. So now we have a cell in our hands, one way or the other. We either got it out of the pool or we out and knitted it. And now we just go along and set properties like there's a property on the cell called text label, and that's a UI label that draws that the main text in basic or in subtitle or left and right detail. So that's the main one. Then there's another one called detail text label. That's the subtitle UI label. There's image view. That's the image view that shows the image, etc. So you just get these cell properties and you set them to whatever you want. And here I've have some method that I've made up called get my data for row in section. That might be something that gets the string that goes there or whatever. Okay? And then you return the cell. Question?
What happens if you want to have like alternating cell types, like maybe every other cell? Can you have two prototypes in there?
Yeah, so the question is, what if I want the cell types to not be all homogeneous? Maybe every other one wants to be a different kind or something like that. And the answer is, and the question is, can I set two prototypes over in Xcode? And no, you don't do it that way. You would have to make them here using alloc and init. But you could have two different reusability pools, just to have two different names, and it could reuse them. But you can't. Xcode doesn't have the UI to specify them. At least I don't think it does. It's possible, actually, now that I think about it. But yeah, so it's perfectly fine though to have. You could have that alternating cell mechanism, but you'd need two different pools. Okay, so that's how you get the cell. So now the only thing left for the table view is how many rows do I have, okay, and how many sections do I have. And it just has two simple methods that asks its data source, how many sections are in this table view, and how many rows are in this section. And that's it. And you just got to answer these questions. Now, the section one, it's so common to have no sections, in other words, one big section, that really no sections is one section, a gigantic section, that if you don't implement number of rows or number of sections in table view, it assumes it's one. Okay, so that's the default. So it's common. However, there is no default for the number of rows in section. Okay, you must implement, this is a required method in this protocol, you have to say how many rows are in a given section. Understandably, if the table view doesn't know how big the table is, it can't make the scroll bars the right size. It can't scroll around and start creating cells when necessary. It just doesn't have enough information. So you have to answer, even if this is 0, you have to return something from this method if you're doing a dynamic table. Static tables, you don't have to implement any of these methods. Okay, just don't implement any of them, and what you do in Xcode will happen. So that's static's very, very easy. Static is more for things like settings and things like that. You still can set values in there because you can have a target action and outlets to them and things like that. But you don't need to do this thing of how many rows, how many sections, give me the cell for that row, because it's all set up in Xcode. Okay? That's new for iOS 5, the static tables. Okay. What else is in the UI table view data source protocol? We're not going to cover them all today. I'm already running late, I can see. But it's things about setting the headers and footers of sections and editing the table if you want to move the rows. That's all doable, but the data source obviously has to be involved if you're moving the data or deleting data in the table. So that's the data source. The other delegate is called UI table view delegate. It controls how the table is drawn, not what data is in the table, but how it's displayed. So things like how tall are the cells and things like that. It's common for the data source and delegate to be the same object, usually the controller, the UI table view controller. You can also observe the delegate has a lot of this did happen, that will happen kind of methods that we've seen in other delegate protocols. Probably the most interesting and important one is it'll tell you when somebody clicked on a row. Okay, that's really important. Now, there's two ways that we can do something when someone clicks on a row. One is just segueing. We can control drag from a row, even a and control drag to something and segue. And if we control drag from the prototype cell, all the cells would do that. So we'd have to make sure and prepare for segue that we prepared the view controller we're segueing to, depending on which row was selected. But you can also find out which cell was clicked on and get a method in the delegate If you're not doing a segue, or if you want to do a segue yourself, kind of a manual segue, which we talked about in previous classes, you kind of have this method, which is a little bit like the target action of the cells. So this method is called whenever a cell is clicked on, did select row at index path, and it passes you the index path, the section and row that was clicked on. And you would do something here based on information, and simple as that. It's just straightforward, exactly what you might think. There are lots and lots of other delegate methods. Again, no time to talk about them all today. The lectures that I give are not intended to be big reference documents about all the methods in all these classes. I'm just trying to tell you how to get started, the general concepts of it. So you can go feel free to look at all these methods and see if something does something you want. More power to you. Let's talk briefly about segueing from table views. It's pretty much exactly what you think. If I have a table here on the left with a prototype cell, and I control drag to some other view controller, then it's going to ask me what kind of segue I want. If I'm on the iPhone, I'm probably going to pick push. If I'm on the iPad, I might be pushing because I might be in a navigation controller inside something, or it might be a split view, and I'm going to use a replace segue on the right. But it's exactly what you think. Segueing is straightforward. When you prepare for segue, okay, so you're doing the segue. Prepare for segue is going to be sent to your table view controller, right? So because you got to prepare whatever you're segueing to, and usually you're going to use this method index path for cell because the sender in prepare for segue is going to be the cell, the UI table view cell that the person clicked on. When prepare for segue gets called on you to prepare for that segue to happen, the sender is going to be that cell. So you're going to say usually index path for cell, get the index path, go look in your model what data needs to be passed to this thing you're segueing to based on what row is picked. Off you go. What if your model changes? So you got this big table, and it's got a bunch of data in it, and your model changes. Okay, someone sets it with a public API, or something happens in a database and changes. You can call this method reload data. Now, reload data reloads the entire table in that it's going to call how many sections in this table, how many rows in each section. It's going to call that for all the sections, and then it's going to call cell for row at index path on all the visible cells. Okay, so it's not going to call that for all the cells, only the visible ones. So hitting reload data is not lightweight because it's going to do all that stuff. And you can call these other reload row at index path to kind of reload just parts of your UI. But if you have a fairly small model, it's not that much work to say how many sections there are and how many rows in each section, and then you provide the cell for the first 8 or 9 visible cells. So reload data, you might well need that in your homework, reload data. There again, dozens of other methods in the delegate as well. I listed a whole bunch of what things you can do, scrolling to certain rows, getting information about cells, all kinds of cool stuff. All right, so the demo. So this demo, it's going to be a little tight on time. It's the favorite graphs. I put up here what to watch for. We'll talk about the first one when we get there. We're going to store a property list in NS user defaults, which you should probably be used to, and you'll definitely need to do it for your next homework as well. We're going to build a UI table view controller and a custom subclass thereof. We're going to implement the data source protocol that you saw today. We are going to have a new delegate. Okay, we're going to do a thing where we implement a delegate. I talked a little bit about this in Dr. Pill demo, but we didn't actually do it, which is what if you have a popover, you put up a view controller via popover, and that popover, something happens in there that it needs to communicate back to the controller. Okay, well, it can't communicate straight to the controller because the popover is part of that controller's view, and we know the view can't just talk straight back to its controller. It has to use delegation. So we're going to do this. We're going to put up a popover. It's going to have a view controller in it. It's going to use delegation to talk back to its controller. We might get to this last thing, I don't know. So I wanted to also take what we're doing back to the original drawings we saw in the very first lecture, the model view controller. So here's what your calculator looks like approximately, right? You've got this calculator view controller, MVC, right? Its model is a calculator brain. Its view looks kind of like that. It's got some target action there like digit pressed. It's got some outlets like display, right? But part of its view is its graph button that brings up this other controller. right? Your graph view controller. Hopefully, this is what you did in assignment 3. So this other controller is part of the view. That's why I kind of drew the little road marker up all the way up to the top of the screen, because this is all part of that first thing's view. Maybe on screen like in a split view controller, but it's still part of its view. And so that MVC, it's got some model, which some of you haven't turned in your homework, so I'm not putting it up here, but that was an important part of assignment 3, understanding what that model was. And it also used delegation. Okay, this was the first MVC that you had to write your own delegation there, which was your graph view data source protocol that had some method in it for getting the data that the view needed to draw itself, and it had outlets like graph view, your controller graph. So everyone, hopefully this is familiar. So what are we going to do in the demo today? So what we're going to do is I'm going to add a button called Add to Favorites. Okay, I'm just going to drop it right in on the graph view. Okay, so what that's going to do is simply going to take the graph that's currently in the graph view and add it to a list of graphs, my favorite graphs, in user defaults, NS user defaults. That's all it's going to do. Okay, that's all the Add to Favorites button is going to do. Then I'm going to add another button, a bar button item called Favorites. Okay, and it is going to use a popover segue, okay, to bring up a whole other MVC that we're going to calculator programs table view controller. Okay, and it's a table view driven MVC that simply has a table in the popover with a list of all those favorite programs. Make sense? And then when you click on one, it's going to update the graph to show you that favorite graph. Okay, so that's what we're going to do today. So I wanted to show you this kind of in MVC model mode, so you're getting clear on where things are. So the model of our new MVC is going to be an array of programs that we're going to get from the calculator graph view controller when it prepares to segue to us. We're going to have to talk back when we click on the popover, okay, one of the graphs on the popover, we have to talk back to the controller to say, oh yeah, they picked a graph, draw this graph for me. But again, we can't talk to calculator graph view controller because it's our controller, right? Even though we're another controller, we're still part of the view of the calculator graph view controller, so we can't talk back to it. So we're going to have to put in delegation. So we're going to create this delegate, and luckily this is a long line because the name of the delegate is long. Calculator graph table program view controller delegate or whatever it is. So we're going to have this long named delegate, and it's the thing that's just going to send a message to whoever signs up to be its delegate that says, yeah, somebody chose a program in my list of programs. Okay, and then our controller will get that thing and say, oh, well, then I'll set my graph to be that. Okay? That's what we're going to do. We go here. Any questions about that before I get started? No? So let's mirror here. Let's go to Xcode. Actually, let's go over here. All right, so here is a solution, not the solution, a solution to assignment 3. I'm not going to show it to you. However, we're going to have to show you some of it to make this work. So here, we're going to do this all on the iPad because I got my iPad here for demo purposes, but we can make this work on the iPhone as well. Notice on the left, I'm only showing you my iPad storyboard, my calculator graph view controllers implementation, and my calculator brains header file, which I'm only showing you. I'm not going to change any code in that. These are the only things we're going to touch. Okay, because we're working entirely in the view side of the calculator view controller, right? So I'm not going to touch the calculator graph view controller. We're not going to touch the calculator graph controller at all. This is all completely independent of that, right? We do not want to be reaching back up. There's no reason for us to be talking that far back in the MVC chain. So this is the only thing we're going to have to change is this, and obviously we're going to have to create our new MVC. So let me talk about the calculator brain change first. Okay, so I said I wanted to store my list of programs in NS user defaults. Well, we know that NS user defaults only let you store property lists. So how am I going to store my programs in that NS user defaults? Well, there's kind of two ways I could do this. One, I could add another class method here called getPropertyList for program, and it would return a property list for me describing the program. And then I could write it, and then I have another class method called getProgramFromPropertyList and pass a property list back to it, right? In other words, convert back and forth. But here's a kind of an interesting API design choice. What if I just put a comment in here that says program is always guaranteed to be a property list. Okay, I haven't changed a single line of code here. Okay, but by putting this comment, first of all, once I put this comment in my public header file and ship it, then I got to live by this forever. So even future versions of my calculator brain would have to agree to make their programs be property lists. Now, we know that our implementation, currently, the program is a property list, right? Because it's an array of numbers and strings, which is convenient for us. But this is why we define the term property list, so that we can say in our APIs, in various spots, this is a property list. It's an ID. You don't know what's in here, but it's a property list. That's all we'll say. Okay? So you see how doing that basically added a whole bunch of functionality to our program without a single line of code? And that's just because we are using that. Now, you know, when we do future versions of our calculator brain, usually you can almost always convert from almost any data structure to dictionaries and arrays and strings and numbers, right? I mean, those are kind of fundamental things. Hopefully it won't get too hairy to have to do that in the future. But it's certainly easy for us to do right now because it's already a property list. Okay, does everyone understand what I'm doing there? I'm just basically documenting my public API that this program ID is a property list. I'm not telling you what it is, whether it's an array or a dictionary or a string. It could be one gigantic string for all you know. But it is a property list. That's all I'm saying. And I'm guaranteeing it forever for this API. Okay? And so now that that's a property list, it's going to be easy for me to store it in user defaults, because I can use the user defaults API. I could also write it to a file, because there are APIs in iOS for writing a property list to a file, for example. Okay? All right. So how are we going to do this? Let's start with the Add to Favorites button. Okay? So I'm just going to go to my storyboard and go down to my graph view right here. I'm going to put this down in this corner down here. I'm just going to scroll. Oops. I'm going to scroll down here to a button, grab a button, put it here. We'll use the little blue things, make it a little wider, call it Add to Favorites. Maybe I'll make sure that my struts and springs are good. Yeah, I don't want it there. I want it sticking to that lower right-hand corner, right? Let's bring up this. Let's make some more space here. I'll try to keep as much space as I can on screen. So let's make this private. Let's go to our calculator graph view controller, right? That's the thing that controls this graph. And I'm just going to control drag over here to create an action. I'll call it Add to Favorites. That's a good name for it. There it is. So when I click this button, all that's going to happen is whatever graph is or whatever program is currently being shown in the graph, I'm just going to add it to an array in user defaults. So what would that code look like? So let's start by getting defaults. I'm going to go user defaults. Defaults equals NS user defaults standard defaults. Too many things. Oops. All right, so now I have defaults. Let's go ahead and get a mutable array from defaults. We'll call it favorites. This is going to be our array of favorite programs. We'd do that by saying defaults, object for key. We need some key in user defaults. I'll be a good programmer here and define it separately. Let's call it favorites key. Maybe we'd call it something like, so it's sometimes good when you have a user default for a class to do something like this. Put your class in there so it doesn't conflict with any keys that some other class might do. So let's say favorites key here. And I'm going to make more space so you can see more. Let's make a mutable copy, obviously, because we're going to add to this favorites, right? So I'm just grabbing an array of programs out of there. It might be that this is the first time I'm ever doing this, though. So if not favorites, if it comes back nil, then I'm going to set my favorites just equal to NS mutable array. All right, create an array. So now I have an array. Even if there was nothing in defaults, I have at least a blank array now. And then I'm just going to say favorites, add object, my calculator program. So my calculator graph controller, I don't know about yours, but mine has a method or property called calculator program, which is the program that I'm currently drawing, okay, in the graph. So I'm just going to add that. And then let's set this, oops, not set URL, set object, the favorites for key favorites key. Turn this chunk. And then we shall not forget to synchronize. Okay? Everyone cool with that? Does that make sense? We're just going to take our current program and just add it to an array of programs that's in defaults. That's all the add to favorites does. Doesn't do anything else. Okay, let's now go back to our storyboard here. And now we need to do this little favorites button that segues to a table view controller. So let's get the table view controller first. Move this out of the way. Just go down here, table view controller, right here. We drag it out. What did I say we do when we drag out a table view controller? We immediately want to create a custom subclass. So I'm going to go to File, New, File, and create a new one. Again, I don't click here. I can click on here, UI View Controller Subclass. I want this to be a subclass of UI Table View Controller, which this is. I'm going to call this Calculator Programs Table View Controller. Some people like to put TVC instead of Table View Controller, but we'll type the whole thing out. To make sure it's in the right place, just fine. It creates it. Probably the very next thing we want to do in our storyboard is go set the class of this thing to be the thing we just created. So I'm going to go to the identity inspector here and change this to be a calculator program table view. So now I've created this table view controller with a table view in it that's my custom subclass. So now I'm going to be able to do all this magic data source and delegate stuff. And in fact, if you look at the thing that was created for me, you can see that it has all the view lifecycle stuff. But it also, look, it has table view data source stuff like number of sections in table view, number of rows and sections, cell for row and index path. So it's kind of put in some code for us. Even has down here did select row and index path, right? It's all commented out, stubbed code, but that's nice. It makes us reminds us that we had to go do all that, implement all that stuff. Okay, so let's go ahead and do the favorite button part of it though, because now that we have this thing, we can create a button to segue to it. So let's go all the way down and get a bar button. So I'm just going to take first, let's click on this. Move up a little. I'm just going to take a bar button and drag it in here. I'm going to call it favorites. Then I'm just going to control drag from it to our new thing here, control drag. And this is iPad, so I'm going to do a popover. Okay, making a pop over here. This is the segue. Click on it here. Let's look at the segue. So it's a pop over here, pop over style. We'll let it come down any direction it wants. It's going to be upper right hand corner, so there's really not going to be that much. We want to make sure we give it an identifier so that in prepare for segue we can prepare it properly. So what does this favorites do? It shows favorite graphs. So that's a good identifier for it. So in prepare for segue, we'll check to see if this is the show favorite graph segue. If it is, then we'll prepare this calculator programs table view controller that we are segueing to show our programs. All right, so pretty much that's wired up. One thing we want to do here inside of our custom table view controller is set up our cells to be the way they want. So I'm just clicking on the prototype cell. This is going to be a dynamic list of programs. We allow any number of programs. I don't really want it to be custom. I'm going to go for basic. I don't really have anything to say except for the description of the program. I don't have any subtitle to show or anything. I don't have an image or any of that. Really important field here is this identifier field, remember, because we're going to have to type that in our code so that the reuse pool gets populated with the prototypes. And so let's call this is basically each line of this is a program, so maybe we'll call this calculator program description. That's basically what each line is going to be, a description of the calculator, of each calculator program, so that's a good name for that. And that's pretty much all we need to do in the storyboard, okay? So we've got everything set up, got this all ready to go. One thing, I probably don't want this thing to be gigantic when it comes up in the popover, so I might also go back here and select the controller itself and go down and say popover, maybe make it 2 by 200. Remember that the table view is a scroll view, so if we have a whole bunch of programs, we'll be able to scroll up and down, so making it small is perfectly fine. So pick some reasonable size there. Now, so that's all we need to do in the storyboard. So really all we have left to do is two things. One, we have to populate what's in there. Okay, we do that with prepare for segue. And then we also have to have our table view controller answer all those questions about how many sections and number of rows and sections and all that stuff. I have to answer all those questions properly. So let's do the latter first. Let's go down here and implement these stubs that are here for the number of sections in table view. One thing, I don't know if you all know about Pragma Mark. Have we talked about that? This is kind of cool documentation. See how this says table view data source? If I go up to here, this bar, and I click on it, you can see that that's a column heading here. See that table view data source? Right? That's matching these methods are here. So this is a good way to kind of navigate around in your code. I personally don't like table views. I like putting the actual name of the protocol here that these methods belong to. Right? So I say that. So then when I click up here, it says UI table view data source, and here's the methods in it. Everyone cool with that? See what I'm doing there? So I'd probably do the same thing down here, because here's my UI table view delegate. Okay, its methods would be down there. Okay, so these three methods, number of sections in table view. Okay, also notice this # warning right there. That is going to force a warning in your code, and they put this in here so that you would pay attention to these two methods because you have to implement them. But number of sections in table view, we want the default, which is 0. So I could return 0 there, or I can just delete this. So I'm going to delete it. Okay, I like there to be less code around for people to have to look at and figure out what it says. So I'm going to do that. But number of rows in section, that we definitely have to implement. So how many rows are in our table? Okay, well, we haven't defined our model, so we don't know. So let's take a time out here and go do our model. And the model for this calculator program's table view controller, I said in the slide, and I said as we were typing here, is a property which is an NS array of programs. Okay? So I'm going to put a little comment in here. It's always nice in your public API to put at least enough comments in this so people know what the heck the thing is. So obviously you would like more comments, but since we're doing a demo, at least I'm going to say this is an array of calculator brain programs. Okay? So we have a warning there, of course, because we have to synthesize it. So let's go back here and synthesize. All right. So now we have our model. Okay, it's not set. It'll get set when we segue to, when someone segues to us, they'll have to set our model for us. But we have enough information now to answer all the table view questions. Okay, so the number of rows in the table is just self.programs count. Right? It's just however many programs are in our array. We're going to have one row per program. And then this cell for row index path is also really easy. Only two things we have to do. One, this cell identifier we got to set to be the same thing that we had back here in the storyboard. All right, so let's make sure, let's click on our cell. Okay, bring up the inspector and be 100% sure calculator program description. That's what we called it. All right, so I'm even just going to copy, go back here, and paste. All right, so that makes sure that if this reuse pool is empty, it's going to use that prototype cell to create it. Okay? And then if for some reason this should return nil, this DQ should return nil, we'll go ahead and alloc init it. Right? You know, this is probably not going to do the right thing because it might not create the right style or something like that, but we'll put it in there just to be safe, I guess. Some people would say don't put this in and let your program crash, because if you don't match this string up. But all right, so we have the cell now, okay, and we just need to set it. So we're just going to set the text label of the cell equal to something. And so what are we going to set it to? Well, we're trying to set it to the program. We know that we can get a nice description of the program, right? Calculator Brain has a class method called description of program. Woohoo, that's a great string to use. We'll use that. And I'm going to enhance it a little by actually saying y equals, because I know that this graph is doing a y equals some function of x type thing. So I'm going to do y equals string by appending string, calculator brain. Okay, I don't have to import calculator brain to get that. I'm only importing calculator brain here to get those class methods, right? The description of those class methods. All right, so calculator brain, description of program, program. Now, where does this program come from? Okay, this is the program that is in the row that we are building the cell for. So we got to figure out how to get that. ID program, right? All the programs in our calculator brain are IDs. We don't know what they are. And the way we're going to get this is just from our programs. We're going to say object at index. It's an array. Our programs is an array. Index path dot row. Remember I told you that these index paths are the section and row of this cell. And we only have one section, so we don't even need to look at the section. And we just need to look at the row, index path dot row. Everyone cool with index path dot row? It's just a property. Row is just a property. Returns an int that tells which row. All right, so that's all. Okay, so now we're able to display all of our programs. That's really all we need to do on the table view side in terms of displaying. The only piece that we need to make this work now is that segue piece, right? Because back in our graph view controller, we're segueing when we click on the favorites button in the little bar button I added. We're segueing, but we always have to prepare for segue. Okay, so what would prepare for segue look like back in our calculator graph view controller? Well, it looked like this. Here's prepare for segue. All right, now here we just do normal segue. Segue if segue dot identifier is equal to string. What did we call that thing? Anyone remember? Show graph favorites or something? Let's go look. It's this segue right here. Inspect it. Show favorite graphs. Okay. I always like to go back and copy and paste. I figure if I always copy and paste that thing, I'll never get it wrong. Of course, then if I change it later, I get screwed. But anyway, all right. So, show favorite graphs. So if this is the show favorite graph segue, then we need to set up the destination view controller. So segue.destination view controller. And what do we need to set in it? We need to set its programs. Okay. Let's make sure we import our new calculator programs table view controller. And what are we going to set the programs to? I'll put a local variable here and we'll decide. It needs to be an array of programs. So I'm just going to say NSArray programs equals NS user defaults, standard defaults, object for key, the favorites key. Sorry, make some more space again. All right, favorites key. That's it, right? We're storing our favorite programs in an array in user default. So I'm just going to grab them and then hand them off to this new thing. Off we go. Okay, that's all we need to do there. Other way. So let's go see if this works. Let's run this thing. Run it on here. So. All right, so here's my my program. It looks pretty good. I see an add to favorites button in the lower right. I see my favorites button in the upper right. That's a good start. Let's see if we can graph something. Let's try my favorite graph, x cosine x. All right, so there's that. Looks like that's working pretty well. Since that is my favorite graph, I'm going to click Add to Favorites. All right, so I'm clicking the Add to Favorites in the lower right. You'll see it highlight there. Okay, so if we've done everything right, cross your fingers. When we hit Favorites, there it is. All right, so there's the table view. It's a table view, scrollable table view with our favorite thing in there. And if I go do a different one, let's do maybe x square root. Graph that. Okay, that's what x square root looks like. Add to favorites. Now we have them both in there. Okay? Question?
If you click favorites, add to favorites again, you would add it again.
Yes, because we didn't do anything to unique these things. We could, and we probably should. We probably would want to do that, go through and make sure it's not already in there. Absolutely, but we didn't. So yeah, so if we added to favorites again, we're going to have two of them in there. Question?
How much data can you store in NS user defaults?
The question is, how much data can you store in NS user defaults? And the answer is, Not a whole lot. For example, if you had thousands of favorite programs, which wouldn't really make sense because they're your favorites, you're not very discerning if you have thousands of favorites. But if you have thousands, that might not be so good, right? But we know programs are fairly small, and so the answer is there's no hard and fast answer. I think a lot of people like to say 100K would be big. You wouldn't want it any bigger than that, and usually it's very small, like 1K worth of data, 1K bytes. All right, so this is good, but we're not quite done because when I click on these, it didn't do my favorite graph. Okay, see, so I'm still getting y equals square root of x even though I clicked on x cosine x. So why is that happening? Well, because we don't do anything when the thing is clicked on. Okay, now when it's clicked on, we're going to get that did select row at index path, and we're going to have to put something in there. And what are we going to put in there? Well, we somehow need to communicate back to our controller, the controller of this whole view piece, that something was selected. Okay, and this is where we're going to use the delegation, because we are part of the graph view controller's view, and we want to talk back to the graph controller to tell it to change its program, right? We need to use delegation. So that's what we're going to do. So here's another example of delegation for you. All right, let me go over here to Keynote. The steps to delegation. Okay, there's 5 steps to delegation. 1, create the protocol that's going to be used to describe the delegation, what's happening, right? Everyone cool with that step? 2, you're going to add a property, either called data source or delegate, usually, in the delegator's public interface. The object that's doing the delegating, okay, its public interface, it obviously needs a property. 3rd, you're going to use the delegate property inside the implementation of the delegator. Obviously, it needs that information somewhere, or it wants to communicate something, you're going to use it. 4th, you're going to set that delegate property in the delegate E, if you want to think of it, the delegate, not the delegator, but the person who is going to receive these messages. It needs to set itself as the delegate, including doing the last side thing. And it needs to implement whatever methods in the protocol that it wants to, or all the required ones, and any of the optional it wants to. So that's it. Okay? So I know that some of you are coming to office hours and you're like, there's so many places I need to edit. Every time I do a delegate, I can't keep it track. But these are the 5 things you need to do. Okay? So just check these 5 off your list. So let's do those 5 things in our Xcode here. If I can find Xcode, here it is. All right, so let's do those 5 things. So the first thing is, let's define the protocol. So do that in our header file over here for our calculator programs table view controller. So I'm going to call this protocol calculator programs table view controller delegate, and it's only going to have one method in it. It's just going to be a notification method. It's going to notify the delegate when a program is chosen. So I'm going to call it, yeah, I am going to do this. Calculator is a controller colon calculator program table view controller star sender, all that just to have the sender, and I'm going to call it chose program. Oops. And I'll pass the program that was chosen just for convenience, like that. Okay? An error because we have to do the forward declaration of the class. Hopefully everyone remembers that. All right? So that's step 1. We created the protocol. This is the only method in the protocol. It's just going to send a message to its delegate anytime someone chooses a program in this table view controller. Question? Why do you need the sender is the question. You don't have to have the sender, but generally it's best practice when you have a delegate to send yourself along. Okay? So that your delegate can call back to you if they have some questions about this program that was just chosen. Now in this case, you're not going to call back. There's no other public API. Although he might call back and say, oh, this program, what was that in the list of programs I gave you? And they could call back and call the programs method or whatever. But it's just kind of good etiquette. It's good delegate etiquette. And then step 2, we need to have a property. It's weak. Okay, almost always delegates are weak because the delegates are almost always somebody who owns the thing that's delegating back. It's an ID with this protocol, and we'll call it delegate. Okay, that's the name of it. Simple as that. We'll go over here and synthesize this. Synthesize our delegate. And then, next step, use the delegate. Okay, so when are we going to use this delegate? Well, every time something is back to here. All right, our favorites. We still have our favorites because they were stored in NS user defaults. All right, so even though we restarted our app, those live. And so if I pick one of these, like x cosine x, it works, or square root. Okay. Make sense? Cool. Question?
If we wanted to show this program in our calculator, would we make the calculator also?
So the question is, if I wanted to show this calculator, you mean if you wanted to say y equals x cosine x? You mean you want to show that?
I chose a favorite program and I wanted to come back to my calculator.
Oh, all the way back up. Yes. In fact, you could set your calculator view controller all the way down as the delegate as long as the MVC in the middle, the calculator graph view controller, exported that implementation detail of itself that it happens to be using this table view thing. Right? The calculator, the guy on the left here, the calculator view controller, he does not know that there's any table view being used on the right-hand side of this. Okay? That's implementation detail of the calculator graph view controller MVC. But the calculator graph view controller MVC could make public the fact that it uses that thing, right? And allow someone else to set that as the delegate. Or it could have its own delegate protocol, which is, here's the graph I'm currently displaying. Just a generic method that the calculator graph view controller will let anybody who wants to know, here's what I'm currently displaying. And anytime it changes for any reason, I'll let you know. That would likely be the way you do it. Does that make sense? So in other words, you might have yet another protocol. The calculator graph view controller lets people know what he's displaying protocol. Probably wouldn't have one that long, but anyway. Is there a follow-up to that?
So then, how do you clear out the NS user defaults?
So your question is, how do I clear out NS user defaults? You mean like you're developing and it's like, oh, I want to try to start over? Yeah, you want to delete the application. Okay, do you all know how to delete an application off a device? No? You want me to show you? Okay, so I am pressing the home button, the hard button on my iPad twice. And when I do that, you see down on the bottom, these things I can switch between apps and stuff, but I can also hold down to kill an app. That would kill this app. Okay, I'm not going to do that because we're doing here, because I'm hooked up to it to the debugger. The other thing you can do is when you go back here and you see this, you got the calculator and the Imaginarium there. If I hold down on the calculator, I also get an X there. And when I hit that X, it deletes this entirely from my device, including the NS user defaults. Okay? Same as on, this is a real device. It works in the simulator too. You can do it in the simulator. Simulator simulates the same thing. Okay? All right, so that's all I have time for. There are two things, actually, that I knew I wasn't going to have time for, but I think you'd like to see. One is the iPhone. What would the iPhone UI of this look like? Right? And the answer in conceptual terms is, when you click the favorites button, it's still going to have a little favorites button in the upper right corner, bar button item for the graph view, but when you click it, it's just going to push the graph on. And then when the delegate method sends a message back, it's going to pop. Remember that method pop view controller? Kind of programmatic way to pop off? That's exactly when you would use it, when a delegate sends you something that invalidates what's currently on screen, so it'll pop it off. Okay? So that's generally what it is. The other thing is deleting. So I got these two y equals square root of x's. What if I want to delete one of them? Okay? So the code for that is incredibly simple. However, we're going to have to enhance the delegate to have another method, which is delete program, right? We already have a delegate method chose program, which gets sent when I click on it. Now we're getting the other one, which is delete, when I swipe to the right and hit the delete key. And then it'll get deleted back in the user defaults. Because this guy, the little table view in the corner, it doesn't know anything about user defaults. It's just got a list of programs. It doesn't know where the heck they came from. The guy who knows about user defaults is the calculator graph view controller, because he's the one managing the favorites, right? So that's why we need another delegate method. So I will post two versions. I'll post exactly this code right here, maybe with a couple comments thrown in. Then I'll post a second one that has the stuff I didn't do in lecture, which is iPhone and delete. All right? That's good. If you have questions, I'll be here. Thank you.
For more, please visit us at stanford.edu.